Hello everyone. In this question it is asked that if a and b are the roots of the equation x square plus lambda x minus 1 upon 2 lambda square equal to 0, then we are to find the minimum value of a to the power 4 plus b to the power 4, where lambda is some real parameter. Okay, so let's start by writing the given equation x square plus lambda x minus 1 upon 2 lambda square equal to 0. If we compare it with capital AX square plus capital BX plus capital C equal to 0, we see that capital A is 1, B is lambda, capital B is lambda, and capital C, the constant term, is minus 1 upon 2 lambda square. Okay, so the roots are A and B. Okay, so the sum of the roots A plus B will be negative of minus capital B upon capital A. Okay, so this means A plus B is equal to minus lambda, and product of roots AB is capital C upon capital A, which is minus 1 upon 2 lambda square. Okay, capital A is 1, so anything divided by 1 is as it is. Okay, so we get A plus B equal to minus lambda and AB equal to minus 1 upon 2 lambda square. Okay, so we have to find the minimum value of A to the power 4 plus B to the power 4. Okay, so let us first start by finding the value of A square plus B square. Okay, so A square plus B square is A plus B whole square minus twice AB. Okay, because the twice AB term is extra, so we subtract this. Okay, so this is A plus B is your minus lambda, so this is minus lambda whole square minus 2 times minus 1 upon 2 lambda square. Okay, we have just substituted the values of A plus B and AB in this equation. Okay, so this gives us minus lambda whole square is lambda square, and this 2 and 2 will get cancelled out, so we are left with lambda square plus 1 upon lambda square. Okay, so far so good, no issues here. Now what about A to the power 4 plus B to the power 4? Okay, this is your A square whole square plus B square whole square, right? So this gives us A square plus B square. Okay, so this is again your A plus B whole square minus 2AB, and in this case A is A square and B is B square. Okay, so here we get A square plus B square is lambda square plus 1 upon lambda square, so this will be lambda square plus 1 upon lambda square whole square minus 2 times A square B square is AB whole square. Okay, so this is AB whole square, right? AB whole square. So this gives us lambda square plus 1 upon lambda square whole square minus 2 times AB was here it is minus 1 upon 2 lambda square minus 1 upon 2 lambda square whole square. So this gives us lambda square plus 1 upon lambda square whole square. Okay, this is lambda minus this will give 2 times 1 upon 2 lambda square whole square gives us 4 lambda to the power 4. Okay, so if we expand the square now, we get first term will be lambda to the power 4 plus 1 upon lambda to the power 4, and that twice every term will be 2 times lambda square times 1 upon lambda square, so we get only 2, and from here we get 2 upon 4 lambda to the power 4, so 2 and 4 will get cancelled, so we are left with minus 1 upon 2 lambda to the power 4. Okay, so 1 upon lambda to the power 4 and minus 1 upon 2 lambda to the power 4, these are like terms, so 1 upon lambda to the power 4 minus 1 upon 2 lambda to the power 4 will give us 1 upon 2 lambda to the power 4, right? It's 1 minus half, something like that. Okay, plus 2. So this is the value of A to the power 4 plus B to the power 4. Okay, so we have to find the minimum value. So for minimum value we need to find some inequality, something like that, right? So let us try to use the inequality of arithmetic mean and geometric mean. Okay, so uh, since lambda is real, okay, lambda is real constant, so lambda to the power 4 and 1 upon twice lambda to the power 4, this will be a non-negative, right? This has to be non-negative, and for this to be defined, lambda cannot be 0 also, because if lambda is 0, then this term is undefined. Okay, so we are assuming this to be positive reals. Okay, so these are positive numbers. So for positive numbers, we know that am of a comma b is greater than equal to gm greater than equal to gm of a comma b if a b are real positive numbers. Okay, so since lambda to the power 4 and 1 upon lambda to the power 4 are positive real numbers, we can use that here. So therefore the arithmetic mean of lambda to the power 4 upon lambda to the power 4 and 1 upon 2 lambda to the power 4, this will be greater than the geometric mean of lambda to the power 4 comma 1 upon 2 lambda to the power 4. Okay, so far so good. So arithmetic mean will be lambda to the power 4 plus 1 upon 2 lambda to the power 4 upon 2, and this will be greater than equal to geometric mean will be a to the power a into b whole to the power half, right? So this is square root of ab. So this will be lambda to the power 4 times 1 upon 2 lambda to the power 4. Okay, product. So this implies that lambda to the power 4 plus 1 upon 2 lambda to the power 4 will be greater than equal to 2 times. If we cancel this lambda to the power 4 and this lambda to the power 4 will get cancelled, and we are left with greater than equal to 2 times square root of 1 upon root 2. Okay, so this implies lambda to the power 4 plus 1 upon 2 lambda to the power 4 will be greater than equal to, if this 2 goes inside the root, it will become square of that, so it will be 4 upon 2, right? So we are left, this becomes cancelled root 2, right? So therefore lambda to the power 4 plus 1 upon 2 lambda to the power 4 will be greater than equal to square root 2. Okay, so what was the value of a to the power 4 plus b to the power 4? Okay, it was here, right? A to the power 4 plus b to the power 4 was lambda to the power 4 plus 1 upon 2 lambda to the power 4 plus 2. Okay, so if we add 2 to our inequality, okay, lambda to the power 4 plus 1 upon 2 lambda to the power 4, this is greater than equal to root 2, right? So if we add 2 to both sides, this will be greater than equal to 2 plus root 2. Okay, just adding 2 to both sides of this inequality. Okay, now this expression on the left hand side, lambda to the power 4 plus 1 upon 2 lambda to the power 4 plus 2, this expression is nothing but a to the power 4 plus b to the power 4, right? From equation 1. Okay, so this is a to the power 4 plus b to the power 4, and this is greater than equal to 2 plus root 2 using equation 1. Okay, so we had to find the minimum value, right? So this minimum value will be this, therefore minimum value of a to the power 4 plus b to the power 4, the least value will be 2 plus root 2, and any other value will be more than that as per this relation, as per this inequality. So the least possible value of a to the power 4 plus b to the power 4 is 2 plus root 2. Okay, so this is it. We just use the value of sum of roots and coefficient product of roots and found out the values of a square plus b square, and then we squared it to find out the values of a to the power 4 plus b to the power 4. And whatever expression we got, we use those terms in that expression. Specifically in this case, it was lambda to the power 4 and 1 upon 2 lambda to the power 4. And since lambda was real, these values are positive. Okay, the case for am and gm inequality, the parameters have to be positive real numbers. Okay, so since lambda is real, these values are positive real numbers, so we use the am greater than equal to gm inequality, and after simplification we found the value was greater than equal to root 2, and then it was like just plugged in the values of a to the power 4 plus b to the power 4. Okay, so this was a small sum, easy sum, relatively easy. Okay, so this is it. Thank you.